Thank you, Livy. I'm super excited to be here at Spotlight. I recently joined Spot from AWS, and I'm really excited to be part of such an innovative company. I'd like to introduce Matthew Zier, the Senior Director of Production Engineering from Lacework. Matthew, thanks for joining us.
Hey, John, thanks for having me.
Yeah, Matthew, I'd like to jump right into it. And can you tell us about Lacework and what does Lacework do?
Sure. So Lacework is really focused on cloud security for the modern age, for cloud-centric or cloud-first companies. We take a very focused machine language-like approach to taking all the data in from machines or from cloud integrations and quantifying what normal behavior looks like. And then we start alerting on deviations of that normal behavior.
It's actually really interesting because I had a chance to read up on Lacework and some of the things you do, and I'm really amazed. And there's some of the things that I'd love to test out and implement and see the value of that. So thank you for sharing a little bit about that.
Yeah.
What is your role at Lacework?
So my team manages the production infrastructure. So if you think about a group of SREs, the group that handles build and release, we're also responsible for how we manage our cloud spend. But this is the team that runs the service called Lacework.
That's interesting. You mentioned cloud spend there, and that kind of ties into the question at hand. How did Lacework get involved with Spot?
Yeah, so I've always looked at the role of production engineering as the keepers of how we use our cloud assets. And I have been a repeat Spot IO customer. And when I started at Lacework, what we were trying to solve for was how can I get things off my plate? How can I automate some of this stuff off my plate, right? And we thought through cost, how we manage our costs. We were fans of using Ocean prior, right? I think the notion of bin packing or playing Tetris with my workload makes a lot of sense. When I joined, we were spending a lot of time manually increasing the compute fleet and decreasing the compute fleet, right? So we recently moved over to EKS. We've automated a lot of the cluster growth. But I think the real magic is in this Tetris, this bin packing piece.
Now, I actually love the frame or the word they're using Tetris, because all I imagine is moving these blocks around. And you started mentioning, how you kind of were managing these workloads before Spot Ocean. What were some of those main challenges that you came into?
Well, it was the same sort of things you'd always run into. You're manually expanding the fleet, or as we reach our peak during the day, you're at Kubernetes is adding capacity or adding new pods. And now there's insufficient compute resources, which triggers alerts. So now instead of doing more important work, I'm now adding compute, right? I'm shuffling compute resources around. So generally you want the team to be focused on running the service, not managing the infrastructure underneath it. I want that to be magic, right? So Spot allows us to do that. And part of the drive too was to think of everything as very ephemeral Spot instance type thing, right? So the other thing is how can I run my workload for the least amount of money? Right? How can I leverage Spot instances in general, and then take that back in engineering? So most of the surface stack can't survive instances going away. We do that in practice because we're running on Spot instances, right? And then I can define my minimum requirements for a compute or CPU, and I can let Ocean figure out what the right compute is for that one, instead of me having to manually think through instance types.
That's actually very interesting on how you kind of described, and like Ocean is handling this all behind, or magically that you called it, behind the scenes, while you can, do further innovation. How did Ocean help with some of those challenges? Do you have a little bit more in depth that you'd like to bring up?
Well, I think in the old way, I would have to manually figure out which instance types match my workload and manually add those, or play with instance types while trying to figure out does the cost make sense to go this one versus this one, and how many pods or services can I launch on this instance type versus something else. That's a lot of cognitive load when I really want the team focused on running the service, not playing around with these underlying components. So Ocean took a lot of that piece off. And then I think that one of the challenges is throughout the day or throughout the workload, we'll see an increase in traffic. And the system can magically respond to that. And prior, we would have to manually launch instances and descale, right? All that is mostly automatic now, right? Ocean can handle a sudden increase. Kubernetes can spawn more workload, and Ocean can make sure the underlying compute can match for it.
Now, you mentioned a couple of keywords there, besides magically doing it, but bin packing, playing a little game of Tetris. Can you describe how container-driven scaling and bin packing has helped Lacework to significantly increase node utilization and cluster efficiency?
Yeah, so I think when I started, we were in some places we were over provisioned, in some places we were under provisioned, right? So an engineer would decide, hey, I need more memory for my thing, and increase the request size for that service, which meant that I would either have to add more capacity, or I'd have one pod sitting on one instance and nothing else could fit on there, right? Because you had to manually shuffle things around. So those would often turn to JIRAs or emergency thing to go add capacity. So I think the bin packing thing lets me shrink the fleet, and we've actually seen that where I had hundreds of workers. I've dropped at least 50 off of them as we've contracted the fleet a little bit. There's a cost component to that, right?
Yeah.
The other metric we're measuring is CPU utilization across the fleet. I want to be north of 80%, and that's reflective of me efficiently using my compute resources. Since I don't get a discount for using less CPU, I'm still paying, right? So we want to be 80% or more, and being able to bin pack everything to a smaller number of computers where my CPU is then again above that 80% helps, kind of directionally helps me understand that I'm using the resources efficiently. And I mentioned that when I started, we had a lot of stuff that was over provision, and a lot of it was because we might need to add capacity, and adding EC2 instances was a delay, right? So now we've contracted all of that. We have some notion of right sizing. We're getting a lot of recommendations out of Spot.io on where pods are oversized or undersized, right? So I think that sometimes you invent a service and you deploy it, and you take a guess at the memory requirements. And then over time, you realize, wow, I guessed really high, right? But without some feedback to shrink it down, you're always requesting more resources than you need.
Yeah, it kind of reminds me of the old days where you were requesting about 20% more of that server that you might reach up to occasionally. And if you don't, guess what? That 20% is sitting there idle, unutilized, and you're still paying for that full server amount.
Yeah, exactly. I think the other, like this can't be discounted too much. I think one of the more important things that Spot is able to give back to us is a cost breakdown per service. I think as an engineering will make good decisions if they have good data, and now I'm providing them actual cost telemetry on what their service costs. So now we can have a conversation whether this service makes sense in this dollar amount relative to other services, and that can go into the engineering priorities, right? So every engineer is actually more aware of what their microservice is costing in comparison to all the microservices, whereas before it was just an EC2 compute bill.
So, Matthew, you were actually mentioning there and talking a little bit about Ocean's Kubernetes native showback chargeback, and then really helping you with that cost analysis and cost optimization. How are you utilizing that within the company?
So we're actually treating that as an SLO, where over time our costs will go up and to the right. So I'm sort of defocusing on the dollar spend. We're treating it as SLO relative to the other services. So John, if your service is now costing twice as mine, and mine's really compute heavy, but for some reason yours is twice the cost, well, now we can figure out why that is, and we can work to reduce that, right? Or we can rationalize why that is. We can also set goals that over time, our SLOs are static as our service increases, right? While the dollar is going to continue to go up, our relative costs are the same or flat, right? So I think that helps set engineering priorities, helps us see where we have inefficiencies in the platform. Like if the authentication service is now 4 times larger than it was last week, that might be a code defect. It might be something to look at, instead of waiting till the end of the month when I get my Amazon bill.
I think chargeback, showback provides a lot of that accountability within the organization and the structure, and really what their application may or may not be doing, and really kind of provide some of that visual value to the environment and where you can have those cost savings.
Yeah, absolutely. I think when you think of engineering in general, you're often thinking about code performance, CPU, memory, but cost is an important factor, right? Especially as a growing startup, that's super important.
Yep.
Right. So I took that metric back in engineering, and we're super transparent about how we're using our resources or how we're spending the money.
That's a good point. Matthew, really to sum it up here, what is the main value Spot brings to Lacework and your team? And what would you say about it?
Yeah, so we have this internal philosophy that we would rather just hang out at the beach, right? And to do that, we have to get a lot of our work off our plate and automate that piece away. So the automated piece that Spot gives us on scaling up and down the fleet, contracting the fleet, helping provide the chargeback or the notion of where our cost is going, making sure we're efficiently using our resources, allows the team to not even focus on that. Now we can focus on the harder problems. How do we scale this thing, right? How do we expand more globally? How do we roll out new features? How do we make the system more efficient? Well, Spot's handling the other piece that we don't have to think about anymore.
That allows you to innovate more, faster, and save money at the same time doing it. So
all of those things, yeah.
I'm glad we could sum it up together. That was a great collaboration on that. Matthew, before we close out, do you have anything else you'd like to add?
No, I don't. Let me see. I think there are other ways I could approach the problem, but I haven't found a way that's as automated or as hands-off. Yep. With the reporting feature, right? I think there are a number of ways I could derive cost per service, but it's now I'm playing with many tools instead of one tool that has everything in one place, right? I think we're a Terraform shop, so being able to automate things or think of using Spot.io as code fits well with what you might think of a contemporary DevOps view as well.
Yeah, I agree with you. And I like that last part that you added there. Well, Matthew, I really appreciate your time here and really giving us an insight on how Spot Ocean has helped the company out. Thank you so much for sitting down with me and having this nice conversation. I really appreciate it.
Yeah, thanks, John. Thanks.
All right. Well, I'd like to pass it back to you, Levi.